various guidelines that one needs to follow for coding standards and coding guidelines, isn't it? And then we also discussed about the code walkthrough, then code inspection, code review. What are those, isn't it? So code walkthrough also we have seen, like basically it's to check by the uh, testers that what are the algorithmic or logical errors that may be there in the particular code. So accordingly, they need to cross check every module, every part of the program, and they need to notify it. Okay, then after code walkthrough, what we have is code inspection. So in contrast or in opposite to code walkthrough, the aim of this one is to discover some kind of common errors, like which may occur due to oversight or human error. You can say you did not remember, or maybe programming style is not proper. So if all these, due to this, there may be certain codes, certain errors that may develop. Okay, so basically, if you are finding such kind of errors, then we are saying that we are going for code inspection. Okay, so code inspection during this stage, the code is examined for the presence of certain kind of errors. Okay, in contrast to the hand simulation of code execution done, like in code work. Okay, um, it may so happen that while suppose passing some arguments, okay, you had to pass two arguments that you, but you had passed only one. So then again, that is basically a kind of a error which has occurred due to maybe an oversight, or maybe you don't have much hang or much control over the hold, you can say, over the programming language. So that may be a kind of a instance where you need to check for code. Okay, so this is basically called a code inspection. So whenever you are not following the particular syntax, or whenever you have committed any error unknowingly, okay, then in that case we say, we don't say we go for code walkthrough, we go for code inspection. So there may be various instances, like for example, you're using a variable but you have never used them. You have declared a variable, okay, in a program, but you have never used it, or you have not initialized it at all. You are jumping randomly into loops, okay, using maybe go to statements. Okay, there may be loops which are not terminating, so it's going through an infinite loop. Okay, there may be assignment statements which not be proper, like for example, whenever you are initializing any kind of value to a variable, it should be like only one initialize symbol, right? But you're putting two, making it equal. So there may be incompatibility. You may be declaring array which may be out of range to what you have declared. Okay, proper usage of constructors and destructors are not being utilized. Okay, so that way all these things, may be the number of arguments, as I said, which it should be passed from the main function less, or it may be no. So there may be a mismatch in the calling of those functions. Okay, not proper use of logical operators, or you're not following the hierarchies of precedence that the operators should be knowing. So all these problems may be there. So whenever these problems are there, you need to correct them. So that time we don't say we are performing a code walkthrough when we are correcting them. We say that we are performing code inspection. Why do we say that? Because there may be two situations where we say that this is a particular case of code inspection. We need to do an inspection because first thing is that these errors you have committed, maybe you did not cross check it once, or maybe it happened because of oversightedness, or maybe it may so happen because of not proper hold on that particular language or technology that you are using. Okay, uh, so that is the whole thing to know. Thing that the question comes is clean room testing. So this is a concept which was taken care by IBM. Okay, so IBM had actually devised this concept. So this type of again, you can say testing works on various kind of things to be done, like walkthrough, inspection, or verification. Okay, so the programmers are not allowed to test any of the code by executing the code other than doing some syntax testing using a compiler. Directly, we're not testing the code. First, we are checking whether the syntaxes, the lines are correct or not. The software development philosophy is based on avoiding by using a rigorous inspection process. Okay, so whenever we are making software, or whenever you all are making a project, you have to software should be error free. Now, error doesn't mean only that there are certain defects, or maybe there are errors in the law, in the, like in C, if you're writing a code, errors you are generating. So errors in this case, it means that the logical part also has to be correct. What you are expecting to get, that you should get. Okay, what are the input values you are supplying? Those input values must be realistic. You have to consider while the system is being made. Okay, and these considerations only will be made possible, or will see the light of the day only when you are clear from day one of what are the various data inputs you will be using, what kind of algorithm you will be using, what kind of processes that will be there. Okay, so all these things you have to decide beforehand, then there will be no kind of issues. Okay, so the objective of clean room testing is that the software which is being built, it should be zero defect. That means there should not be any defect. Okay, zero tolerance, you can say. So the name clean room was actually derived from the analogy with semiconductor fabrication units. In these units, that means in clean rooms, defects are avoided by manufacturing in ultra clean atmosphere. So whenever this designing and fabrication of the semiconductor chips or units are being done, so they are done in a very clean and sophisticated environment, so that the defects or any kind of issues are not, are being handled. So it is just an analogy. That means the way it is being handled in a very ultra clean atmosphere. Similarly, when the software is being developed, one has to check that all the specifications are being met, and whatever we have thought about of what are the things it will be needing. Okay, the data inputs, the processes, the algorithms, all are being utilized, and everything is in order. Okay, so that's why it is called that there is a similarity between that. So that's why it derives the name from there. These are not required actually. Yeah, this is very important. Software documentation. So whenever you are making a documentation, what are the things you need to document? So user manual is very important, because once you have developed the code, how you are going to make the use of the software, what is the significance of the graphical user interface, or whatever the interface you have developed. Okay, how a layman will be able to use it, isn't it? So that user manual has to be written, documented in a very proper format, because ultimately there has to be a beneficiary for your project, isn't it? There has to be someone who will be using your project. So keeping that in mind, the user manual has to be very neatly be written and documented. Again, SRS, like for any project when you are building up, so you need to lay down the software requirement specification very, very nicely, because if your SRS is well defined, then only you will be able to go to the analysis and design phase, and ultimately be able to implement it very, very correctly. You need to design the documents, like what are the algorithms you have used, what are the data structures you have used, what are the subroutines or functions you have used, isn't it? Then even the test cases. So the test documents will be dependent on SRS, because for different like SRSs, you need to validate it in the testing phase. So those test documents also has to be there. How you are going to install it. So even the installation manual has to be there, so that it. Okay. So good documents are very useful and serve the following purposes. Like good documents always help you to understand better of how a software, of what the software does. Okay, how it should be maintained, what are the functions the software has. Okay, it also helps the users to use it very effectively. Okay, and good documentation actually helps to uh, handle the manpower turnover problem. So if suppose the software is doing the work that you can say 3 humans are required to get it done. So if suppose one has a good understanding of how the software works, then that will be very efficient in handling the manpower or human resource of a company. Okay, so documentation is very important where you have to explicitly state that what are the things is required for the software, in which platform the software will be running, how it was, not how, but in what technology it was built, who are the beneficiaries, how it can be used. Okay, so all these things has to be documented very well by the project manager and the team who is making the software. Okay, so once this documentation is processed or it is made, then it has to be reviewed before the deployment of these documents to the client side. So this has to be taken very, very seriously so that you will be able to get it. You can like reach out to the people. Okay. So as we said that again, software documents can be classified into two kinds. One is internal documentation and the other one is the external documentation. So in the internal documentation, you have to specify the source code also. Okay, the coding, you have to say what are the variables you have used, how many variables you have used. Okay, each variable, what is the job of each variable, what kind of data a particular variable is storing, what are the software packages you have used. Okay, what are the classes that you have employed for maybe implementing a particular module. So all these things has to be specified very nicely in the internal documentation. So internal documentation will be basically be maintained by the development company only, so that if a prospect of maintenance comes up, then in future that maintenance is carried out very nicely and properly. Okay, so that's why how the internal documentation is being used. Whereas in case of external documentation, this is basically from now the client side. So the client, you have to give them like user manual, okay, how the software has to be like used step by step, no, or the SRS, okay, then the test documents. So all these things will be given to the client side. Okay, so question, maybe you can add to the list of assignments. So this is the question, maybe you can add, like what is coding, then what is coding, then what are the characteristics of a programming language. Tomorrow I think is the deadline for second assignment, right? What are the characteristics of programming language? And this one is very important, write down the coding standards and guidelines. Okay, write down the coding standards and guidelines. So tomorrow, first one I think I have received. So tomorrow I will check the second assignment.
Okay, sir.
Okay. Then another question you write, what do you understand by code review, code walkthrough, and code inspection? What do you understand by code review, code walkthrough, and code inspection? So next topic that we have is for testing. Again, testing is a very important topic because most of the questions again are asked. At least 2 to 3 testing methods will be asked in your exam. So you need to know this chapter very, very well. Okay. So what do you think can be testing or program testing, and what is the need? Can anyone tell me? Yes, anyone?
So, like using testing, like we see if the program is working properly or not, and if there are any like bugs which stops it from working.
Okay, so basically what we are doing, we are trying to test with certain test cases that whether if there are certain bugs which are there, if suppose the program doesn't gives us the output or doesn't behave the way it is expected to behave, then basically we need to debug, we need to hunt the errors and we need to correct it, isn't it? So that is basically testing. Okay, so basically common use in testing are like there may be a failure, there can be a defect or a bug. So you need to locate that bug and you need to fix it. Okay, then test cases will be there. So in test cases, you need three things: the input to the software, the state, because when you give the input, the software is expected to give you the output. But during that like phase of transition, right, when you have given the input and then it will pass through series of states, isn't it? Different states, okay, and ultimately gives you the output. So that is also very much familiar, okay, when we are talking about testing. Then O is basically the expected output from the system or from the software. So test suite is basically, we may have so many use cases or test cases which is there. Like for login process, what are the things, test cases that it may be there. So data input will be user ID and password. And then when we give that, there can be two possibilities again. That means two test cases will result. One is if the user ID and password is correct, as that is being stored with the like user ID and password that is stored in the server to what we have supplied, isn't it? Then what will happen? We can log in into the system successfully. So that is one of the test case. Similarly, there can be another alternative or another test case is that if suppose if one of the parameter like user ID or password is incorrect, then it will throw an error message. So this is also one another test case. So whenever we are uh, testing, we need to be very much here about what are the various test cases, and we need to like come up with these test cases not now, but during the SRS phase only. Okay, software requirement specification only. So that thing we need to know. Okay. Now, aim of testing. Why do we need to test? As we said that we need to identify the defects, we need to hunt them, locate them, and we need to remove them, isn't it? So that our product is error free. So that is very, very important. We need to check also like whatever the input data we are taking, whether it is too large that it can consume a lot many resources. So the practical when suppose whatever we have conceived in paper, but when you are going to do anything in practical, there is a lot of difference because theory and practicals are two different uh, cases. So that is the reason we need to understand that if suppose we have said that okay, I need an input data of let's say image file I need to supply, but we need to see that whether having so many image files also as input data, whether it will be very much practically feasible for the resources that we have. Okay, if it is feasible, then it's fine. But if not, then we need to check from the other angles as well. Then another important definition that is being asked in your exam is differentiate between verification and validation, or they used to ask like define verification and validation. Okay, so verification from the name itself, it means that what? It is a method of finding out whether the output of one part of a software conforms to the previous phase. Okay. Whereas validation is the process of determining or finding out whether the software that we have built or the system that we have built, okay, it conforms to the specification that we had written down during the SRS phase. Okay, so in verifying, actually, in verification, we are actually finding out whether the output, whatever of one phase, that means of one module of software, okay, it conforms, okay, to the previous phase. Whereas in validation, what we are doing, we are validating. That means we are confirming whether the software that was thought of being how it will work, okay, what is the expected output we will be getting, so whether that is uh, coming into reality or not, as we have thought about the entire thing. Okay, so that is basically the uh, difference between verification and validate. Okay, so while verification basically it's more related to the location or finding out the errors module wise or phase wise, the main objective of validation on the other hand is basically the aim is that the final output or the final software should be error free or it should be bugs free. So in verification, we are more concerned that the errors should not be there in every module. Whereas in validation, we are checking that ultimately the final product should be error free and we should get the output that we are expecting. Okay, so one is basically on the higher level and the other one is on the general level. Okay, so that you can say. And this also they used to ask like differentiate between functional testing and structural testing. Yeah, this may be asked. One question you can add, like why uh, black box testing is known as functional testing and white box testing is known as structural testing. Okay, so this is also very important question. Why black box testing? Again, black box testing and white box testing, they are a kind of testing strategies. So different types of testing methods and strategies are there. So accordingly, we need to know it. Okay. So far, any questions?
No, sir.
It's very theoretical, right?
No, sir.
Yes, sir. It's very theoretical.
Okay. So that, but these are actually implemented when you start working, no? Okay. Because now what is happening, like you are knowing what is happening. I can understand that you are understanding also what is I'm trying to say. But practically, if you don't implement in your atmosphere, then it becomes difficult. Yeah, one more thing I remember just now. From Vision Magitech, actually, he called me today, the MD, and then he was asking me regarding some names were sent there, right? If I'm not mistaken, he told me. Yes, isn't it?
Sir, but I don't know about Arbas if he sent